joined this session, you're probably in the intersection of mobile testing and game testing, unfortunately for you, because it's quite challenging. Gaming and testing are two different, two like different problems to tackle. And when you're in the intersection of both of them, you share both of the challenges. Testing in general is important, but specifically for mobile apps and even more specifically for gaming, it is super important. Just a couple of months ago, Google announced that they're going to be ranking the apps in the App Store based on their quality level, amount of crash reports and stuff like that, and the responsiveness of the app. So testing and quality is critical for mobile apps. So it's super important to have high quality mobile apps, although it's sometimes challenging to test them. And if you look at the landscape of mobile game testing, you'll see that most of the mobile game testing is still manually. I mean, obviously there are companies that are more advanced than others, but you see a lot of manual testing across the industry. If you look into automation solutions, and there are automation tools in the market and open source tools, really good open source tools, but it's still perceived as very, very complex. I mean, you have, if you look at, let's say, the most popular framework, Appium, and you try to combine it with mobile gaming, it looks very complex to automate on top of that. And we'll touch the challenges in a minute. Also, these tests tend to be quite unstable, so they're very sensitive to changes. Gaming, especially, I mean, the UI is usually very rich, and these tests tend to fail for like many different reasons. In general, mobile gaming is slow, and you have to work with devices and stuff like that, so that makes it even more expensive. And slowness and expensive is generally part of the experience when you're talking about mobile testing. You have to have like different devices, even if you're using cloud devices. You need emulators and simulators, and it can be expensive, and still it's very, very slow. So let's talk about why mobile testing is hard. So as I mentioned, you have to work with devices and emulation. It's pretty difficult. You look at the table of a Q engineer, mobile gaming company. You see a lot of devices on the table, cables and stuff like that. Although they're pretty good like emulators and simulators, and they're like pretty good cloud vendors that supply sort of like cloud labs for emulation. There's a lot of work involved around that. Every time you get like a new APK or new version of your app, you have to upload it to the device to test it. It can be pretty time consuming. And also, if you look at the frameworks that you have to, specifically we talk about UI testing, the frameworks that you have to work with for like clicking buttons in the UI, you have to locate the elements on the UI. For some reason, it's more challenging to do for mobile than to do for web. The standard for web locators is pretty solid, although there are like different strategies and stuff like that. But for mobile, it's more difficult. You have to really like sometimes struggle to find the right way to locate the elements you're trying to interact with, and yeah, it's still there's a stability problem, and the UI for mobile games is very rich. And as I mentioned before, speed is also a factor. So you have to upload a new version of your application to the mobile device, even if it's a cloud device or something like that. You have to upload that. It affects the speed. These tests tend to run pretty slow, and they're pretty hard to parallelize. So if you're trying to simulate like a multi-user scenario, playing like a game from like both like multi-actor gaming or something like that, it's pretty challenging. You have to like synchronize between the devices, and it also affects the speed. And it's also hard to parallelize multiple tests running in parallel, because you need a dedicated device. You can't run usually two tests on the same device at the same time. And as I mentioned, building installation, just building the APK every time and creating a new version of the app, even for iPhone, it's pretty time consuming. It takes a lot of time. There's a lot of DevOps involved, and it can be pretty challenging. And these are the challenges for mobile testing. And if we talk in general about the challenges for gaming, there's also challenges in testing games, which make them specifically difficult to test. So one of my personal favorites as a challenge in gaming is randomness. When you're writing tests, especially automated tests, you want them to be as expected as possible. You want them to be as repeatable as possible. You want every time to verify a specific behavior. But games tend to challenge this concept by being random. I mean, if you're playing like a card game, you won't get the same cards every time if you play the actual game. And there's a lot of challenges around that. How can you take this randomness, which is like built into the concept of gaming, and test that in a repeatable manner? So that's a big challenge in gaming. Also, gaming tend to have like time-based events. Specifically, if you look at mobile gaming, you have like events, calendar events, something that happens only on a certain hour, certain date, something like that. And it creates another problem because we want to run our tests exactly right now. So how can we simulate something that maybe takes like a couple of hours to happen? So let's say you have like, some currency that you get every couple of hours. How can we simulate that? How can we test it? It's pretty challenging because we want our tests to run fast. We don't want to wait a couple of hours until we can verify our test. Also in gaming and in general, there are test dependencies. So for example, to test level 99, you have to probably go through all the levels before that. So obviously there are solutions for that, but it creates a lot of dependencies. If you want to test a certain skill in the game, you might need to unlock all the skills up to that specific skill. So that creates a lot of challenges. And also gaming tend to be multiplayer. So you have multiple actors playing the same game. You want to synchronize between their actions. It's very challenging. And you combine that with the overall challenges of mobile testing and gaming testing, and together you get a very challenging task. I want to start by mentioning a couple of the strategies that I think, obviously there's a lot to that, and we won't cover everything in a short session, but some of the strategies that I think people should think about, these are like the low-hanging fruit, or the thing that you should start by when you're thinking about testing mobile games. And prioritization is the first one, because this is such a challenging task, you sort of like have to admit that you probably won't get to cover everything with your automated tests. There's something that's still going to be kept for like manual testing, and you have to prioritize to find your ROI sweet spot. So you need to think about where the places that can automate as easy as possible to cover as much ground as possible and save as much time as possible, and still have like a reasonable timeline to implement this sort of automation. So prioritization is important in general for every task, but especially when we're talking about mobile gaming, you need to sort of like admit that you won't be able to automate everything from day one, and create sort of like a reasonable timeline for that. Another thing that is really important for me around mobile game testing is splitting between the UI and the backend testing. It might be obvious, it might be not obvious, but usually the release for like the UI, the actual application that is uploaded to the App Store, and the backend of the applications, they sort of like have different cadences, because you control the backend. You can push to it new changes usually whenever you want. And if you want to push new version of your application, it has sort of like a different cadence. You need to go through the approval of the App Store usually. So companies usually don't release for the for the App Store as often as they do it for the backend. So it makes total sense splitting the testing of these two concepts, because they have sort of like different release cadences. Another thing is also might be obvious, but cheats needs to be baked into the product. I mean, we need to make it possible for us to test the game in some ways that the players can't interact with the game. So cheats, and I don't know if everyone knows that originally were invented to help the testers to simulate conditions in a non-linear way, not like the player, right? If you want to test level 99, you shouldn't need to play all the levels up to that, right? You need a cheat to make it possible. So cheating, it's kind of symbolized for me something that testability need to be baked into the product in general. In other products also, you might find yourself implementing stuff that is dedicated specifically for testing, and that's definitely okay. And the gaming industry sort of like learned that a long time ago. Sometimes it's hard for developers to develop something that only helps the testers and not the actual product itself. But in gaming, you see that it was done a long time ago, and it makes total sense. And multi-actor testing is sort of like a concept, not a strategy, but it's also something that you need to think about. If you have a multiplayer game, and many of the games, even the classic and casual games today, have some sort of like multiplayer baked into them. So you need to think about that. You need to think about how you can do that. If you think about UI testing, it's very difficult, right? So it's also sort of like related to the split between the UI and the backend testing. And there are many different types of mobile games, so not each one of them will benefit the same testing strategy as the other. In very high level, and I don't want to talk about the details because obviously some people will come to me and say that I'm completely wrong about that. But in very high level, casual games, hyper casual games, which I'm kind of like putting aside, usually don't get tested very, very deeply because they have sort of like a short lifespan, and they're like keep changing every time. These are like the hyper casual, super casual games. There's like much more effort that is put into the design of the game than into like the actual logic and the mechanics of the game. So usually they don't require as much testing, and also they don't tend to live very long. So they keep like changing in the marketplace, so they don't get tested very deeply. I don't know if it's right or wrong, but this is just the situation. But classic casual games and casual games are worth testing, and I'll show a couple of examples of that. But basically speaking, the more complex the game is, the harder it is to test it, right? So if you're talking about like action games and adventure games, it might be sometimes really hard to test the mechanics of the game itself, but through the UI, but it is doable. If you talk about like hardcore games and mid-core games, like really action games with live action or sport or racing or something like that, testing through the UI is extremely difficult. Even testing through the API might be extremely difficult because there's like a lot of going on through the game. But this sort of like puts us back in thinking about prioritization, what I can test, what I need to still test in a manual way. And the more complex the game is, the harder for you it will be to test like the core game itself. But you can think about like all the other features that you have around it, right? You have like a marketplace, you have the login, you have a lot of other elements that make up the game. And in casual gaming, you can do a lot of that anyway. In mid-core gaming, it's a bit more challenging. Maybe we'll get to see an example of that in the end. So yeah, I talked about it, but splitting here the UI and the backend is super important. I think it kind of puts us back on the general guideline of the testing pyramid that you sort of like it makes it especially true for mobile gaming, right? Unit test is still super important. It's still very cost effective, right? You don't need a device, you don't need an environment, you don't need anything. UI testing is extremely expensive and complex, right? So you want to have as few UI tests as you can. Obviously, you have to test the UI, and especially you have to test for different devices, right? You want to install your app on different devices just to make sure that it makes sense on different devices. But still, the API layer, you should probably use it for whatever you can, right? It's super effective, especially to test the backend of the game, which can change a lot. And I think the pyramid makes total sense when we're talking about mobile gaming. So the alternative that we suggest for like manual testing and for classic UI testing is basically what we call deviceless testing, right? It's sort of like a take on API-driven testing, right? We cut through the UI layer. We don't test the app itself. We analyze the app basically just to map all the user actions into end-to-end API tests. And we're validating the actions and the states itself. We don't validate the visual aspects of the game. and we basically reduce UI testing and keep it mostly to the happy flow, and also validating different device types. So I'm going to show it in demo in a second, but basically how we do this strategy. To create the test, you still look at the mobile app to map the interactions into API calls, but you don't need them to actually run the test, right? So we start by taking the mobile game. I'll show it in a second. We run the traffic of the game that's going through to the server through a proxy. We capture everything from the proxy, and we upload that the log of the API calls to LoadMill. And what we do at LoadMill, basically, at the heart of the system, there's an algorithm which analyzes API calls and turns them into automated test code. So we have this test code written. These tests are basically testing your app through the API layer. These are like deviceless tests. You don't need the device to run these tests. They will test directly the backend, but they'll do it in a manner that is sort of like correlated to the behavior of the user in the actual mobile game, right? And the benefits of deviceless testing is basically all the opposites from what I said about the downsides of UI testing, right? It's super fast. These tests run really fast. You can run them in parallel because you don't actually need a device to run the tests on. They're super stable comparing to UI tests because UI tests tend to break very easily for UI changes. And these tests are not sensitive to UI changes at all. And also the API tends to be backward compatible for many different reasons. It's basically like the contract between the mobile app and the backend. So it tends to be pretty stable, although, I mean, there are some maintenance involved and changes. And it's very efficient. You don't pay for the devices. It's just like runs on the traffic on the network layer. It's super efficient. It's also much easier to maintain these tests. These tests are sort of like mapping between the user flow and the API calls that they send to the server. So it's very efficient. I mean, it's very readable. It's very easy to maintain. So there are a lot of benefits around that. And yeah, so I think now I'll give a few examples to what I mentioned. Each example sort of like, I will try to highlight some things I think requires some attention. So I'll start with the first game. I don't want to do like any finger pointing to anyone. I know everyone works really hard on the games. I don't try to like provoke or say anything bad about anyone. Everyone makes mistakes, but I just want to highlight some bugs and some things I think worth testing. So I took this example for a casual game because I think it's a pretty good game. Let's focus on that. Let's do the chess later. So this is sort of like a chef table game. You can see right off the bat that testing it through the UI, it is possible, but it's quite challenging, right? I mean, it's very rich UI. It's not so easy to play around with. I'm basically using it through a real mobile device to interact with it. And there's a lot of tests around it, right? I see the hearts on the left side. I see the currency, the coins on the right side. So a lot of things to test around that. You can test like the marketplace. It's probably super important to your, monetization experts that this part of the product will work perfectly, right? And just some of the things I want to highlight through API testing. So what I did here is basically I captured the traffic from this game using a proxy. Just like poked around a little bit. I got to see all the different API requests that are being sent while I play the game. And you see there's a lot of API being involved with every action you do here. Everything is sort of like sent an API call to the server. I basically took all these APIs calls or some of the relevant ones and saved them into a file and upload it. Let's save it to a file. And I uploaded it to LoadMill to create a very basic test scenario. Let's go with the test that I prepared for here. And this is a very simple test, right? I basically get the list of the versions, a lot of stuff that I don't know what actually is going in the game because I never worked on it or developed it. I just like recorded the traffic. But using LoadMill, I create sort of like a really solid game with description of everything that happens in the game. So getting the player profile, updating the player inventory. And this is something I want to linger on a little bit. So this is actually the request that once I play something in the game, or I don't know, take some bonus or something like that, this is the actual API call that updates the game inventory. And here in this game, in this game, we're actually sending the number of coins. So the client side is actually updating the number of coins that the user have. And using this, if you look at what I have right now in my inventory, I have like 3,000 coins, right? If I actually send a different value and run this test, it will actually update the number of coins that I have. And this is something sort of like, I think it's borderline security, I think, testing, but it's something really important to test, right? If this API basically tells the server how many coins I have here, right? So now I just like update it to have like 4,000 coins. If I'll refresh the app and reopen it, right? I can see that I actually updated the number of coins that I have. So this is something that you can do through the UI. So no UI test or manual test will ever catch that, right? But if I'm testing through the API layer, I can test a lot of stuff that you can do through the UI, right? And this is sort of like important to validate that the customers, the users, they can do that, right? So I just updated the number of coins that I have, right? So some of the tests that you will do through these sort of like deviceless tests, they can cover stuff that no user can do through the UI, but you want to validate that it's impossible, right? You want to validate that you can't update your coin numbers to something that's not decided by the system, right? It's basically cheating. So this is one example. Another example I want to give is so that was a casual game. Another example I want to give is leeches, right? So I did a video about that before, and I captured sort of like a game in leeches, and you can do a lot of other stuff with classic games. I think chess is the classic game. So you have here some API calls involved. When you start a game, basically it opens a WebSocket connection, and the traffic for the game goes through WebSocket connection. So I think this is not the right one, but we'll show it here. So basically, I captured the game through leeches, and I created a test here. And here we open a WebSocket connection to actually like test the game. And we actually play a basic chess move through the WebSocket connection, and we resign the game immediately afterwards. But the point that I want to mention here is these sort of like live games involve WebSockets. And this is, if you think about it, so gaming is, as I mentioned a lot of time, multiplayer thing. So WebSockets is one of the things that you see a lot around multiplayer. You have to try to sort of like think in this multiplayer way. It's sort of like a bi-directional communication, and WebSockets are sort of like a big thing around that. So you basically need to think as like sort of like two actors in the same test, right? You have your one user playing one side of the game, and the other user is playing the other side of the game. If you do it as a UI test, you actually have to have like two devices playing the game in parallel, right? But if you're thinking through the API layer, you can sort of like mesh up two scenarios from two users into a single game. You can give each one of them like different authentication. And when you run that, you'll get a game played by two players. Another thing is you can use bot for that. So sometimes you want the other side to respond to you be a bot. Sometimes bots have other use cases. The actual users get to play with them. But yeah, this is basically what I did here. I played against the bot, and basically started a game with the bot. I moved my e4 pawn, and then resigned the game. So very basic testing. This sort of like serves to show that for classic games, you can still actually test the game itself, right? You can actually do actions in the game. Although with UI testing, it is possible. It's quite difficult, right? You have to sort of like locate a square on the board and actually like drag and move a chess piece on the board. It's very difficult, right? But through the API layer, you can still test like the core logic of the game, right? Actually like play a game of chess. So it might be challenging. I won't choose to play a full game of chess through the API. It's very difficult, but you can still like poke around it and, test like some critical moves. So this is something that you can do with classic games. The last example that I want to show is for mid-core games. This is more challenging. And here you have, again, you need to think about prioritization. So this is the League of Justice game. It's a very, very graphic rich game, right? It's like live action games. People are actually fighting here, and it's very hard to test. So you have to have some like hard decisions. Here, it will be very hard to automate around like the actual game itself, right? Like the actual fighting itself. It's very, there are a lot of clicks involved. No locator in the world can basically actually locate and click the game itself. You can also think of bots as a way to test that, and it is a valid strategy, but it's very challenging. I won't log in into the game itself, but it's very challenging to test the core game. So what you can do here is basically test everything around it, right? You might still manually test the core game itself, but you can test the store through the API, because there are a lot of APIs involved in the store, and also through UI testing. It's still a valid solution. I basically created sort of like I'm testing the login of the game, because it's still an important part, right? And we still have it in our like manual test cases, right? And it's also good to cover everything that can save me time for manual testing. Maybe I'll still need to do the core game itself through manual testing, but I can test everything around it, the marketplace, the challenges, the quests, the everything around it. I can still test with automation. So this is where prioritization comes into play. Yeah, I think basically that's everything I want to cover today.